Guys, let us look at second example on solving trig equations. This time we have more like a quadratic type of an equation where I have 4 times sine square x is 1. Our goal is still to solve for x, and we know x is, in context to this particular trig equation, is the angle, right? So in order to solve for x, the first step is to isolate the sine square x. To isolate, we divide both sides by 4, and when we divide both sides by 4, we get sine square x. So from here it implies sine square x is 1/4. Guys, from here we cannot just directly go into the unit circle and start looking for the values for x that give me sine of that equals to 1/4, because there's a square with the sine. So how would we get rid of the square? Because if I get just sine x by itself, then I should be able to just directly go on to the unit circle, or if you want to use a calculator, you can also use a calculator sometimes. But guys, right now for those values that are visible on the unit circle, the standard values starting from 0 and 30 and 45 and so on, I would suggest that we should look at the unit circle and not really worry about using a calculator at this point. And then so basically we have to get rid of that square, but we know how to get rid of a square. Like if I have an equation of the form x square equals to something and I want to solve for x, what would I do? I would just take the square root on both sides. And guys, that is what I have been trying to tell you in my previous videos, that solving trig equations is kind of similar to solving algebraic equations. So what you would do for an algebraic equation, you would do kind of similar thing for a trig equation, but then there's few other things which involve like using the unit circle and some other things. Okay, so taking the square root on both sides, what do I get? I get sine of x equals to square root of, but when I take a square root, I will have plus minus 1/4, right? That means I will have two values. Sine x will be 1 plus 1 over square root of 4, which is 2, or I will also have sine of x is, I will have two values. The other one would be a negative 1/2, right? These are my two values. Now from here, since they're in sine and sine in linear forms, guys, now we can just go back to the unit circle and see for what angles we get x, sine x, positive 1/2 and negative 1/2. Let me start with positive 1/2. Guys, for positive 1/2, we know that sine is positive in the first quadrant and the second quadrant. So that means I only have to look in the first and the second quadrant for this guy. For this guy, sine is negative in the third and the fourth. So then for this particular value, I only have to look into this third and the fourth quadrant. Basically, we're looking in all the four quadrants, but still we should narrow our search. For this particular value, it's only first and second. For this, it is third and fourth. I'll start with this one. For this one, I'm looking at my unit circle. I know the sine values are the y values, right? So looking at my unit circle, what I see, the first one is 30 degrees. And I'm going to start writing those. Guys, I get the first one, 30 degrees. Then the second one, I'm still looking for positive 1/2. So I already looked into the first quadrant. Then I have to look into the second quadrant. In the second quadrant, guys, I get 150. So I'm going to write 150 degrees. That takes care of the positive 1/2. And let us also write the equivalent radian measure. So it's pi over 6. And this is 5 pi over 6 radians. And guys, that takes care of positive 1/2. Then the next one is for this one, negative 1/2. Now I'm going to look into the third quadrant first. For third quadrant, I'm getting 210. So I have 210 first, and then I will look into the fourth quadrant. This covers all the quadrants, 210. And then I have the last one. In the fourth quadrant, I have 330 degrees. So guys, you got to have a unit circle in front of you if you are working on solving trig equations. 330 degrees. And let us look, also write the equivalent radians for that. 210 is 7 pi over 6. And this guy is 11 pi over 6. So guys, these are the four values that we can see in the unit circle from 0 to 2 pi, but we already know that there's no restriction on the values of x. So these guys can kind of keep on going forever, or they just we can go around the unit circle n number of times or infinitely many times. So all we have to do here is With all of these, we have to just add 2 pi k plus 2 pi k plus 2 pi k, again plus 2 pi k. If we are using the radians, guys, if we are using only the degrees, then it would be plus 360 degrees k and 360 degrees k plus 360 degrees k, same thing, plus 360 degrees k if you are using the degrees, right? And because we know 2 pi radians is 360, and there's one very important thing that we have to write if we want to really complete the whole problem, the solution for the whole problem, which is that k, what does k stand for? Because if you are writing any variable, here we are writing k, we have to mention what does this stand for. So k stands for, k is any integer. So it can be a positive integer or it can be a negative integer. Guys, that completes the solution for this equation. This was slightly more challenging than my previous example. Previous one was a simple sort of a linear type of an example, but here it was a quadratic form, so we have to take the square root. So when we take the square root, obviously we'll have both positive and negative values. So in this case, we have not just 2, we have 4 angles, and then we have to keep on like adding 2 pi k to each one of them, since there's no restrictions for the x values, the angles here. Okay, and we know again sine function is also an periodic function. It just goes on forever in the positive direction as well as in the negative direction. Guys, this is example 2. I will see you next time with example